All right, today our next lesson in our probability unit is going to be on experimental probability. That's the title. In your table of contents, write the title, experimental probability. And then on the next clean sheet of notebook paper in your spiral notebook, the title at the top of the page should be experimental probability. And then the essential question for today is, in what situations is conducting an experiment a good way to determine the probability of an event? Hit pause, set up your notes. When you're ready to move on, hit play. All right, the first thing that you need to copy into your notes is everything on the screen. And I'm pretty sure this is all the notes for today, okay? How do you determine the relative frequency of an event? That's our question. In a probability experiment, you carry out or observe an action repeatedly. Each observation of the action is a trial. What that means, observation of the action, each time you flip the coin, each time you roll the number cube, each time you spin the spinner, each time you do that, we call each of those a trial, okay? And you're going to keep track of the total number of trials, so the total number of times I flipped a coin, the total number of times I rolled the number cube, whatever, and the frequency of each possible outcome. You can use a ratio to find the relative frequency of a given event in the sample space of the experiments. And our little formula to find the relative frequency of an event, this is the same really as the experimental probability. You're going to put the number of times an event occurs over the total number of trials. So let's say I flipped a coin 100 times, and 55 of those times I got heads. If I was telling the relative frequency of getting heads, I would do 55, the number of times I got heads, over 100. And write that as a fraction. Then I can simplify the fraction from there. Okay, so make sure you have everything here copied down, the definitions and the formula. Let's try an example. Call this example 1 in your notes. So we're looking at this spinner. And the spinner has been spun, it tells us in the problem, 40 times. We spun the spinner 40 times. Then it asks, what is the relative frequency of the event for spinning a number less than 4? Now remember, less than 4 does not include 4. So less than 4 would just be 3, 2, and 1. So they tell us in the first row of the table what the outcome is. That means the number that the spinner landed on. And then below it, they tell us the frequency. That's the number of times it landed on whatever number is above it. So since I'm finding the relative frequency of spinning a 3, 2, or 1, those numbers that are less than 4, I'm going to just add the frequencies together. So I got a 1 10 times. I got a 2 12 times. So 10 plus 12, that's 22 so far. And then I got a 3 4 times. So I did 10 plus 12 plus 4. So together, 26 times I got a number less than 4. Out of how many trials? Out of 40 trials. Can I simplify that fraction? Yes. So I can divide it by 2, and that would be 13 out of 20. I can also convert that to be a decimal if I want to. Sometimes the digit problems will ask for a fraction. Sometimes you can put a decimal. If I wanted the decimal, I would just divide in my calculator, top divided by bottom. So 13 divided by 20 would be 0.65. So as a decimal or as a fraction right here. Make sure you have that in your notes. That should be called example 1. Well, whatever. I went to the next slide. You know what I mean. All right, this next one, let's try. This is example 2. You should do this one in your notes with me as well. All right, example 2. Same problem, same spinner, same frequency table here. Okay, same. But the question is a little different. So suppose this class spins the spinner 40 more times. Do you expect the relative frequency of the event spin a 2 to change or remain the same? So the first time I got 12 out of the 40 times to be a 2. If I spun it 40 more times, do I think I would get exactly 12 2s And I would probably say no. I would expect it to probably change. I would expect, if we're spinning it 40 times, and there's 4 different numbers it could land on. It could land on 1, 2, 3, or 4. I would expect it to probably be around, I'm going to say approximately 10. Okay, if there's 40 spins, there's 4 numbers. But it might end up being 12. You just never know with experimental probability. It can be close, but maybe not exactly the same as the last time you do the experiment. Okay? Suppose the class spins the spinner 400 times in all. Is there a value that you expect the relative frequency of the event spinner 2 to be close to? Well, when I look at this spinner and I see that the 2, how much of that spinner is the 2? I divided this into fourths. The 2's make up 1/4 of the spinner. So if a fourth of the spinner is 2, what would be 1/4 of the 400 times that we spent? A fourth of 400 would be 100. I would expect 100 out of the 400 spins to be 2's, because I see that the 2's take up 1/4 of the spinner. Now, if I actually spun the spinner 400 times, it may not be exactly 100 2's, but it would probably be pretty close to that. Okay, one more slide. Experimental probability. We need to write down this definition and this formula. How do you determine the experimental probability of an event? Copy this into your notes. You need everything on this slide. You can use relative frequencies to estimate the probability of an event. A probability found this way is an experimental probability. So we're seeing that the term relative frequency and experimental probability mean the same thing. Okay? The greater the number of trials, the closer the experimental probability will be to the actual probability of the event. Okay? This is our formula. When we see this P parentheses event, what that means is this in parentheses is going to say something. So it might say P parentheses heads when we're flipping a coin. What that means is we're finding P, the probability of flipping a heads. Or it might say P parentheses even number. So if we're rolling a number cube, what's the probability of rolling an even number? Okay, so whatever's in parentheses is what we're finding the probability of. And our little formula here, the number of times the event occurs over the total number of trials. How many times did I flip that coin? How many times did I roll that number cube? Okay, make sure you have all this copied into your notes before you move on. Okay, a cashier in a grocery store asks each customer what type of bag to use. The table shows how many customers requested each type of bag during the cashier's 3-hour shift. Find the experimental probability that a customer asks for plastic bags. So we're trying to find the probability of asking for plastic bags. Write the probability as a fraction and as a percent. So we're going to start with the fraction. So plastic, how many customers requested plastic? 18. How many total customers were there? They didn't give it to us, so we have to add these together to get the total. 18 plus 6 is 24, plus 8 is, what would that be, 32? So the total is 32. 18 out of 32. Can I simplify that fraction? They're both even, so I know I can start by dividing by 2 on top and bottom. That'll be 9 out of 16, and that's as far as I can go. So 9 out of 16. How do I change that to a percent? Well, first I have to change the fraction to a decimal, and then from the decimal I go to the percent. How do I go from a fraction to a decimal? I just divide the fraction. So 9 divided by 16, I get 0.5625. And then to go from a decimal to a percent, I just scoot the decimal over 2 times. So it would be 56.25%. Okay, so you might have a question where they ask for a percent. You can't remember how to do that. You divide the fraction to get the decimal, and then you multiply the decimal times 100. That's the same thing as moving the decimal over 2 times to get the percent. Last example. This should be example 4 in your notes. Find the experimental probability that a customer will bring reusable bags. So again, looking at the table this time, reusable bags is right here. We have 8 customers out of, we said the total was 32. 8 out of 32 use reusable bags. I can simplify that by dividing it by 8. And that would be 1/4 as a fraction. They didn't tell me to do a percent, but I could. If I divided 1 divided by 4, that would be 0.25. If I converted to a percent, that would be 25%. So we would say about 25% of the customers, about 1/4 of the customers bring their own reusable bags to the store. Okay? At this point, you should be ready to start on the digits. 16.3 for this unit. When you finish that, go on to the Unit 15 IXL skills. You have your spiral review, and then you can work on missing assignments if you get all of that done.